In this lesson, we will be looking at the rates of chemical reactions and the factors that can affect reactions. Reaction rate is really the speed of the reaction, and it can be defined as the amount of a reactant consumed. So the amount of a reactant that is consumed, or the amount of a product formed in a given amount of time, or the amount of a product formed per unit of time. We can see that reactions take place at different rates. For example, rusting is a slow process where burning something is really fast. We're going to look at this example, magnesium metal reacting with nitric acid to form magnesium nitrate and hydrogen gas, to look at reaction rate. So the reaction rate for this example can be defined as either the mass of reactant that is used up over time or the amount of product that is produced over time. So reaction rate equals mass of magnesium reacted divided by the reaction time. Or we could measure how much gas is produced, and we could say the reaction rate equals the volume of H2 produced divided by the reaction time. So looking at this again with actual numbers, if we used up 2 grams of magnesium and we reacted it with hydrochloric acid and it took 40 seconds, then we could say the reaction rate is the mass of magnesium reacted divided by the reaction time. The mass of magnesium that was used is 2.0 grams. The reaction time, 40 seconds. So 2.0 grams divided by 40 seconds equals 0.050 grams of magnesium per second. So what is it that makes reactions go? Well, the answer is within the particles themselves. You've probably already studied the kinetic molecular theory, but just to remind you, the theory suggests that matter is made up of tiny particles, and those particles are in constant motion. In solids, the particles are close together, and they really just vibrate back and forth. In liquids, the particles have small spaces, and they move quite slowly. And in gases, the particles are spread apart and move very fast. The collision theory says that in order for moving particles to react, they have to first collide. So in order for moving particles to react, they must first collide. And this should make sense. In order for particles to undergo any kind of reaction, they have to come into contact with each other. And not only do they have to collide, they have to have what is called effective collisions. And these are collisions that have enough energy to overcome the repulsion between reactants and break down the necessary forces and to bring about the reaction. So effective collisions have enough energy to overcome repulsive forces that exist between reactants and break the necessary bonds to bring about the reaction. So in any group of collisions, only a fraction of them will be effective. So now we can say that a chemical's reaction rate is determined by the number of effective collisions that occur in a given amount of time. Next, we are going to be looking at factors that can affect the rate of chemical reactions. First one we're looking at is concentration of reactants. So concentration describes the number of particles present in a given volume. If we increase the concentration, this will increase the reaction rate by increasing the frequency of effective collisions. So increasing the concentration of a reactant increases the reaction rate by increasing the frequency of effective collisions. For example, a stronger acid reacts fast with magnesium or faster than a weak acid. A stronger acid would be more concentrated than a weak acid. The next factor that can affect the rate of reaction is the surface area of the reactants. The surface area is the amount of a solid that is open and exposed, so it's kind of available to react. So increasing the surface area of a solid reactant increases the amount of exposed solid and thereby increases the reaction rate by increasing the number of effective collisions. So for example, if you have powdered sugar, you would expect it to dissolve faster than a cube of sugar because every bit is exposed already in the powdered sugar. Next factor we're looking at is temperature. Most reactions have a higher rate of reaction at a higher temperature. For example, hamburgers are going to cook faster if the pan is hotter. So if you increase temperature, you increase reaction rate 2 ways. This is reaction. So you increase temperature, increase reaction rate 2 ways. First, by increasing the frequency of collisions. And second, by increasing the energy of all the collisions. Sugar cubes dissolve faster in hot water, for example, than they do in cold water. The fourth thing is adding something called a catalyst. And a catalyst is a substance that increases reaction rates, so that increases the reaction rate without being used up. It lowers the amount of energy needed to make the reaction go, but it is not used up in the reaction. So it lowers the amount of energy needed to make the reaction go. Enzymes are an example of catalysts, and they're catalysts in living organisms. That help make reactions go faster. The last thing that can affect reaction rates is something called inhibitors, and unlike the rest of them that made things go faster, adding an inhibitor will make it go slower. So it's a chemical that prevents or slows down a reaction. Chemical that prevents or slows down a reaction. For example, people often attach zinc plates to boats because boats are in water all the time and they don't want them to rust, and zinc will attract the rust to it and keep it away or slow it down from happening on the rest of the areas.